Today we are going to be looking at how you would perform a calculation based on a balanced equation. Okay, so there are 5 steps to do that. The first one is make sure that the equation is balanced. Step 2 is to write down your mole ratio, and we'll talk a little bit about what mole ratio is when we're working through some examples. Step 3 is to calculate the number of moles that you actually have. So the mole ratio is kind of like, in a perfect world, what would we have, and the step 3 is to calculate what we actually have. Step 4 is going back to our mole ratio. So now what you're going to do is you're going to use the number of moles that you calculate in step 3 and make yourself a new mole ratio. And step 5 is to calculate what the question is asking you. In most cases, step 5 will be asking you to calculate the mass. And I would be making sure that you're writing down those 5 points so that you can follow them every time. So now what I'm going to do is we're just going to work through some examples and we can show each of these steps at a time as we reach them, okay? So, example 1. What mass of carbon dioxide will be formed from 4 grams of methane? And they've given you your equation there. Now, the first thing to do is have a look, is it balanced or not? So let's have a look. 1 carbon here, 1 carbon there. 4 hydrogens here, 2 times 2, 4 hydrogens there. 2 times 2, 4 oxygens here, 2 oxygens and 2 oxygens, 4. So it's balanced. So we can tick it off and say yes, the equation is balanced. Now what I tend to do before step 2, before I look at that mole ratio, is I have a look at what I actually want in this equation and I rewrite it. So what mass of carbon dioxide, I'm interested in this one, will be formed from 4 grams of methane, CH4, and this one. So I can cross these 2 out because I'm not going to use them, and I would rewrite that. So I would write CH4 and CO2. Okay, and then my next step is the mole ratio. How many moles do I have of this? Okay, if there's no large number at the front, it means we've got 1 mole. So here we have 1 mole of methane, and at this side we have 1 mole of carbon dioxide. So that's us done the first 2 steps of our 5-step checklist for calculating these equations. Step 3 was to calculate the number of moles. Okay, we know the mass of methane, so we can do number of moles equals the mass divided by the gram formula mass. The mass of methane from the question is 4 grams, and we can calculate the gram formula mass from our formula. So come down a little bit. CH4 1 times 12 and 4 times 1 is 16. Okay, so then if we bring that up here, 4 divided by 16 is the same as a quarter, so it's 0.25 moles. And that's step 3 done. So we've now worked out the number of moles that we actually have. So back up here to our mole ratio. In an ideal world, we would have 1 mole of methane giving us 1 mole of carbon dioxide, but what we actually have is 0.25 moles of methane. So if we do a little bit of cross multiplication, we'll find that 0.25 times 1 divided by 1 will give us 0.25 moles. Because it's a 1-to-1 ratio, so the same amount of methane will produce the same amount of carbon dioxide, so 1-to-1, 0.25 to 0.25. And then if we move on to our final step, now the final step is calculating what the question is asking you. If we take a glance back up to our question, it asks you what mass of carbon dioxide will be formed. Okay, so to calculate the mass, we rearrange our triangle and we get mass equals number of moles times gram formula mass. We know our number of moles because we've just calculated it, so it's 0.25 moles. And we can work out our gram formula mass. So carbon dioxide, CO2, and that's 44 grams. So 0.25 times 44, a quarter of 44 is 11 grams, and that is your final answer. So that's the 5 steps that you do. Step 1, make sure the equation is balanced. It was fantastic. Step 2 is look at the mole ratio that you have from the equation, from the balanced equation. Step 3 is calculate the number of moles that you actually have, okay, using the information that's given you in the question. Step 4 is working out the actual mole ratio. And step 5 is calculating what the question asked you. Okay, so now what we're going to do is we're going to go and have another look at another example. And this is actually from a past paper question. It was from the 2019 Nat 5 past paper question 5. Okay, cyclohexane can be made by reacting ethene with butadiene in a reaction called the Diels-Alder reaction as shown. Okay, calculate the mass in grams of ethene required to make 410 grams of cyclohexane. Okay, so first thing, check is it balanced? 2 carbons here, 4 carbons there, 6 and 6, perfect. 4 plus 6 gives you 10, so it's balanced. So first step's done, we're balanced. Then what I would do, have a look, what do we need? So we're saying calculate the mass in grams of ethene you required to make 410 grams of cyclohexane. So straight away we can get rid of this butadiene and we can rewrite this as C2H4 to C6H10. Okay, and the second step then is a mole ratio. No big number at the front. 1 mole to 1 mole. Now, what's happened here is actually what we've done is we've flipped it. So instead of you working out the number of moles of your reactant, okay, and then using that to calculate the mass of your product, they've done it the different way. They've done it backwards this way. So they've actually told you the mass of the product and they want you to work back the way and figure out how much reactant they put in. So what we're going to do is have a wee look over here, number 3, work out the number of moles of reactant I've got. So number of moles equals mass divided by gram formula mass. The number of moles it tells us in the question is 410. Sorry, the mass it tells us in the question is 410 divided by our gram formula mass, C6H10. 6 times 12 is 72. 10 times 1 is 10. So our gram formula mass, is 82. 410 divided by 82 is 5. So we have 5 moles. Step 3 done. So then we go back to step 4 and it's a mole ratio. The only difference is we're working from right to left this time. Okay, so 5 moles times by 1 divided by 1 over here. So our 1 to 1 mole ratio became a 5 to 5 mole ratio. Okay, and then moving on to our final step, which is to calculate what the question's asked us, and the question is asked us to calculate the mass of ethene. Mass equals number of moles times gram formula mass. The number of moles we just calculated to be 5, and our gram formula mass we can work out. C2H4, 2 times 12 is 24, and 4 times 1 is 4. So we've got 28, off the page again, 28 grams over here. 5 times 28 gives you 140 grams. And that is your final answer. Okay, and with this question, because it is a past paper question, it says calculate the mass in grams, which means you must give your units for that final step or you would lose a mark. The third example that we are going to look at is when we're doing a calculation based on an equation and we don't have a simple 1-to-1 mole ratio. Okay, so let's have a look at this one. Calculate the mass of iron that will be produced from 16 grams of iron oxide. So first step is to have a look and see if that equation is balanced. 2 iron, 2 iron, the oxygen here, the oxygen there, 6 in total on our reactant side, 3 times 2, 6 in total on our product side, and we have 3 carbons and 3 carbons, okay? So we can tick that off and say yes, our equation is balanced. Now again, what I would do at this step is I would read the question through and see which of these I'm interested in, which I'm not. So calculate the mass of iron that will be produced from 16 grams of iron oxide. So I can cross these out and I can rewrite it. Now this time when it comes to my second step, my mole ratio, here we can see I've only got 1 mole of iron oxide. However, I actually have 2 moles of iron. And then just like we've done previously, we go into step 3 when we're working out the number of moles. So number of moles equals mass divided by gram formula mass. The mass it gives us in the question is 16 grams of iron oxide. We can work out the gram formula mass a little further down. Fe2O3. Iron is 56. We've got 2 of those, and oxygen is of course 16, and we've got 3 of those. So to add that up, we've got 160. Bring that number up, 16 divided by 160. 10th, and we've got 0.1 mole. Okay, so this is the number of moles that we actually have. Let's hope we can back up here and do step 4 now. So the mole ratio, this would be our perfect mole ratio, and this is what we actually have. 0.1 moles. Again, you do a cross multiplication, but this time you're going to get 0.1 mole times by 2 divided by 1, so you'll get 0.2 moles of iron produced for every, so for every 0.1 mole of iron oxide, you're getting 0.2 moles of iron produced. Okay, and then we can take this number of moles down and do step 5. So calculate the mass of iron that's produced. Mass equals the number of moles times the gram formula mass. Our number of moles is the 0.2, and our gram formula mass is just for iron. Okay, so the 2 relates to the mole ratio. Okay, so you never include the big number at the front when you're calculating your gram formula mass. Okay, so Fe, we know that that's 56, so 0.2 times 56, so a fifth of 56 is 11.2 grams, and that is your final answer there. And that's how you would do those examples for when you don't have a straightforward 1-to-1 mole ratio, you've got a 1-to-2. You might even get an example where you have a 2-to-3 mole ratio, and it's just the same. So if this was a 2-to-3 mole ratio, this number we would times by 3 and then divide it by 2 to get a final answer. You just need to remember to do that cross multiplication step.